All right, so on example 7, real quick, make a quick modification. This should say plus 7 instead of equals 7. So change your paper so it says plus 7, not equals 7. So the equation is y equals 3x squared minus 9x plus 7. Now, it asks for the maximum or minimum value of the graph of the equation. We've already done problems like that using one technique, the vertex technique. You may still know how to do that, you may not. Maybe you remember, maybe you don't. All right? But if you remember that, the other thing it's asking for is the vertex form. And that's something you haven't done before, and it's a new technique to do the same thing. So I want you to learn how to do this because it's a useful skill in math in general, to be able to make a vertex form or a standard form of an equation. So let me just give you an idea of what vertex form looks like. Vertex form of a quadratic equation. Y minus k equals a times x minus h, the quantity squared. That's vertex form. And k and h and a are numbers. X and y represent variables in the form. X and y are part of the form. H, K, and A all represent numerical values. They're going to be numbers that are known based on what's going on in the problem. As far as what you need to know is this. A is just the regular A value. So if y equals ax squared plus bx plus c, that A is that A. Whatever number's in front of x squared, that's what A is. All right, it's the same A we've been working with this whole time. All right. The vertex is coordinates h comma k. Now I want you to notice in the structure, the form, it says y minus k and x minus h. The vertex is positive h and positive k. So we're subtracting h and k. So whatever is here and here, we take the opposite sign to get down to here. If we have this, we go the opposite sign to get back to here. So it's kind of whenever you see minus in mathematical formula, that means change the sign of whatever it was. So if you want h, it's opposite of what you see in your picture. If you want k, it's the opposite of what you see in your picture. This is what we have, and we want to create that form out of this. And there's a technique for doing it. It involves completing the square. There's only one little weird little spot that happens in this, and it's explained in example 6 also. So either this video or the other video will give you the same weird thing happening. So first thing, I want this to look like that. Everything that's not x comes over here. Everything that is x stays over there. So the first thing I'm going to do when I'm trying to make vertex forms, I'm going to isolate the x's. I want the x's on one side, not x's on the other side. So I'm going to start by taking this plus 7 and slide it over to the left. So that gives me y minus 7 equals 3x squared minus 9x. Okay, that's first. Next, I want to create a binomial squared, an x minus h squared structure, which we get by completing the square. Okay, if I'm completing the square, and we've already done this quite a bit now, we should be getting kind of accustomed to how to do it. It's very important for completing the square, that has to be 1x squared. That's the most important thing when I'm completing the square. 1x squared, more important than anything. If a fraction show up, that's more important than x. It's got to be x squared, not 3x squared. I don't care if fractions show up. All right? I can deal with fractions. I can't deal with 3x squared. So, if I want to make this x squared, I'm going to have to factor my 3 out. I don't care what happens to anything else when I do this. I've got two objects here. Whatever this value is, this a value, I pull it out. X squared now is left because I divide by it. Negative 9x divided by 3 is negative 3x. It just so happens that divided evenly, even if it didn't. Even if that said 10x, this ends up being minus 10 thirds x, I don't care. Minus 10 thirds x is much easier to work with than 3x squared. So pull that 3 out, divide everything by it, whatever happens to the rest of the problem, so be it. Leave a little space in parentheses. Over here, just keep it y minus 7. That step has nothing to do with the left-hand side. We're just setting up the right-hand side to complete the square. Now, we're completing the square. Same completing the square we've been doing this whole time we've been doing this section. We're going to take half of b, which is 3 halves, and we're going to square it. It's always plus. Okay. This is the weird part. before I get to the weird part, let me make sure everybody understands what I just did. B is 3, negative 3 specifically, but we just pretend it's always positive for this purpose. B is 3, half of 3 is 3 halves, and we square it, right? What's 3 halves squared?
6 over 4. Now,
3 squared is 9, 2 squared is 4, so 9 fourths, right? So I've added 9 fourths over here, right? So what we would do usually is we'd add 9 fourths over here, right? But let's consider what I really added, because I did add 9 fourths right there. Where is 3 halves squared located? On the right-hand side, where? Inside what? The parentheses, right? This 3 halves squared is located inside this parentheses, right? So this 3 halves squared is also being multiplied by this 3, just like these two things are being multiplied by 3, right? 3 times x squared is 3x squared, 3 times negative 3x is negative 9x. Both of these things are being multiplied by 3. This is also being multiplied by 3. So I added 9 fourths, but I really added 9 fourths times 3, so I added 27 fourths on that side. So I have to add 27 fourths on this side. That's the weird part. This is 9 fourths, but it's really 27 fourths because it's being multiplied by the 3 that's out there. Do we all see that okay? That happens almost every time you try to make vertex form. If there's a number in front of x squared, there's a number going to be here. It's going to multiply by that. That's going to modify this thing over here. These are not going to match each other, but the real value of it will match the real value of it. So, over on the left-hand side, I have to add these things up. What do I need to do to negative 7 to add 27 fourths to it? Not make it positive. Do what?
28 over 4.
And make it negative 28 over 4. So this negative 7, this right here, has to add the 27 fourths. In order to add negative 7 to a fraction, I need to make negative 7 become negative 28 fourths. Right? Negative 28 fourths and negative 7 are identical. But this is subtractable because we have a common denominator. So y is y. Negative 28 fourths plus 27 fourths is negative 1 fourth. Over here, I got my 3 outside. I got my parentheses squared now, right? I've got a trinomial here, and I'm trying to factor it to a binomial squared. The square root of x squared is x. The square root of 3 halves squared is 3 halves, and the sign in between is a minus sign. So we go from your standard basic form of a quadratic equation into our vertex form of a quadratic equation. So I know for a fact that the vertex of this thing is going to be positive 3 over 2, positive 1 fourth. The number with x, change the sign to find x. The number with y, change the sign to find y. That's what it says. Number with x is the x part. The number with y is the y part. You have to change the signs though. If it says minus, you put plus. If it says minus, you put plus. Finally, it says what's the maximum or minimum value for this graph? Larson, what's A's value here? In this problem here?
that'd be 3.
3. Is 3 positive or negative?
Positive.
Positive.
Minimum.
If
Will you let me talk, please?
A is positive, that means the graph goes like this, right? Turns upward, which means the vertex is a minimum. And when they ask for the minimum value, they're asking for the y-coordinate of the vertex. So this one has a minimum of positive 1 fourth. All right? So that's how we make the vertex form of a quadratic equation. Again, it involves completing the square. It involves a little bit of distributive property. It's a little bit complicated, but it's something, again, if you practice the technique, it's systematic. It works very nicely. You just have to be careful with it.